Hello, it's Dean with another tutorial, this time about how to interpret ABGs. It really can be pretty simple if you just follow a few easy steps, and so I want to show them to you now so that you can get through these ABGs and be able to figure out what's going on with your patient. So I made this little chart here. You can look through it, but sometimes it seems too complicated. What I really want you to look at is the normal value of each pH, the CO2, and the bicarbonate, because you really have to know those values. And for the purposes of this tutorial, the bicarbonate is the bottom of the range is 22, not 21. Depending on the references, you may see different numbers. So for this purpose, we're going to say the range for bicarb is 22 to 26. If your pH goes below 6.8 or above 7.8, guess what happens? Yeah, not good. So here are a few little tips for successful interpretation. You really need to know those values, as I mentioned just a minute ago. And we treat patients, not machines or numbers. So if your patient history says a certain thing or your patient looks a certain way, believe that and match the values that you find on your lab results to what your patient looks like. And you need to do what works for you. I'm going to show you my way. It works well for me, but whatever you do, do it the same every time. And there's no substitute for practice. So once you do a few of them, you'll get a little better. Once you do a lot of them, you'll be way better. So you may want to use a cheat sheet or some kind of little chart to help you remember the values. This one's kind of helpful too, where you can see if the pH is going down or up, in the accompanying other values with the CO2 or bicarbonate. So you may want to look through that. Create something like this for yourself, but like I said before, do whatever works for you. Mnemonics are sometimes helpful. This one's one that I liked. ROME, R-O-M-E, stands for respiratory opposite, metabolic equal. This is to remember that the values, as the value for CO2, for example, the smaller the number, it's actually getting more alkaline, or the pH is going higher. So it's opposite for the respiratory. Metabolic, it goes in the same direction. So if the value of the HCO3 is going down, then it's getting more acidic as the pH number gets smaller. So it goes in the same direction. So ROME, just remember respiratory opposite, metabolic equal, and then you'll be able to apply those values. So this little method that I like turns this super easy system to be able to put it in the right spot, and then you can clearly see what is the interpretation. So you just make a tic-tac-toe. You've all played that before. So this middle column of boxes will be our normal range. Acid side. So acid's over on this side and base over on that side. So anything that is less than 7.35, my threes are not working out very good, and the base over here, 7.45 on that side, and higher, and lower over there. So your base, remember, that just means you're alkaline. All right, so let's do some of this. If you want to quickly write down the values so you can remember them on the side of your little paper or whatever you got going on, and that's always easy for me. When I was in school, I did kind of a memory dump on paper when I went into the testing area, so I could remember some of the math equations or values of different things so that I didn't forget, because I got nervous in tests. So if you want to do that, just go ahead and jot them down like I did here off to the side so I can remember those normal values, because it's really important. So I reverse these instead of being in normal order, like you would have the smaller on the left up to another value, I flipped them around to remind me that they're the opposite. So it helps me remember if I put the range like that and I have a number greater than 45, it's on the left. And that's where the acid goes. Now we've got some values here. Let's practice. So our pH, we're going to start there, 7.25. That is on the acid side. So we're going to write the pH over there. Bicarb. Is it normal or acid or base? Look over here at my range. It's on the high end of normal, but nevertheless, we're going to call it normal. It is in the normal range, so we're going to put it there. CO2, 61. That is higher than normal. That puts us over to the left on the acid side. So now we've got our values in their places. pH is acid, so it's something acidosis. And then all we're going to do is look to see which of these two is on the same side as the pH. And it's the CO2. So it's respiratory acidosis. Not too bad. Let's try another one. Another value, pH is 7.15. Again, that's lower than normal. So we put our pH on the acid side. Bicarbonate is 16. That is lower than normal, also on the acid side. CO2, 30. That is on the base side. So now we have opposite values of our key players here. Runs us into some trouble. So the pH is something acidosis. The bicarb is on the same side as the pH. So now we know it's metabolic. Metabolic acidosis, but we have this guy over here that's out of range as well. So what's happened is the respiratory system is trying to pull that pH back over into the normal by moving itself over into the basic side of things. It's not worked because the pH is still out of normal. So this is a partially compensated blood gas. So it's partially compensated metabolic acidosis. Let's try another one. 7.45 on our pH. So that's normal, but if we were to draw a line down the middle, this is going to be on the base side of normal. All right, so our pH is there. Still normal, but it's leaning very far, almost out of range to the base side. So that's, we're going to have that be in the back of our mind. Bicarb is 29, which is on the base side. Our CO2 is 85, which is on the acid side. So now we had the same situation like we had before, only in reverse. The difference is our pH is normal. So what do we call this thing? It's leaning on the base side. So this is our real key player, and we're going to name it metabolic because it's leaning over to the base side, and the bicarb is on the same side as the pH there, leaning. And so what we're going to call this then, because the pH is normal, it's totally compensated. So it's compensated metabolic alkalosis because it's on the base side. Okay, one more. Then you'll have this for sure. So your pH is 7.36. Oh, look, right in the middle, but it's on that acid side of normal. Bicarb is 20, which is also on the acid side. CO2 is 18. That's on the base side. Situation similar before, only opposite. Our pH is normal, so it's compensated. Which value is on the same side as the pH? Our metabolic. So we're going to have compensated metabolic acidosis. Not too bad. You can do it. A little more practice and you'll have no problem.